This lesson is about transformations. And transformations are something that you've been working with probably since first grade. You've been working with several different types of transformations. There is a reflection, there's a rotation, and there's a translation. There's also one called a dilation, which we're not going to do anything with today. But hopefully you remember a reflection is a flip, FL for flip. A rotation is a turn, T for turn. And a translation is a slide, SL for slide. The types of transformations that we're going to be doing are going to primarily be in the coordinate plane. So we're going to be making our X and Y axis, just like we've been doing for the last few lessons. And we don't need a very big one for this. Make it a little bit bigger. Okay, I'm going to put a few points on here. I'm going to start with the point -3, 1. That'll be point A. I'm going to start with -1, 1, point B. And I'm going to go with -1, 3. That'll be point C. I'm going to connect all these points. It's going to make a nice right triangle. And what we're going to do is reflect it. So we're going to reflect it across the y-axis. We can also reflect across the x-axis. We can reflect across the line y equals x, which is the diagonal line that goes through the origin. Reflect across it, but we're not going to do that. What we're going to do is reflect across the y-axis. And the way we do that is see how far away we are from the y. So right here I'm 1 unit away, so I'll go over here. And that's where the C would move to. The B, 1 unit, and then the A, move 1, 2, 3 units, so 1, 2, 3 units. We can connect all those, come up with our new triangle. A problem that we run into is that now we have two things in the same graph that are labeled the same. We have an A here and an A here. The way we deal with that is we call this one A prime, this is B prime, and this is C prime. Prime is just another way of saying that it's the same thing, but we've changed it, or we've moved it, or this is the second version of it. This triangle, triangle ABC, was our first triangle. It's called the pre-image. This is a vocabulary word that you should have had, so it shouldn't be new to you. Pre-image means it's the first image. The second one over here, or the result of the transformation, is called the image. So that's simple enough. And what we can say about this transformation here is that we took triangle ABC and we turned it into triangle A prime, B prime, C prime. Now if you notice when I wrote this little statement here, I used this arrow. This is called arrow notation. And when I drew the arrow, I said turns into. Technically what you'll hear, or the way you'll probably hear it in a higher math class, is that this arrow means maps onto. But maps or mapped is just a fancy way of saying it turned into or it became. Now, something that you're going to need to be able to do that's different, I'm pretty sure up until this point you're fine with all of this. What we're going to have to do is write rules for these transformations, or we're going to have to read rules and do the transformations. So a rule is just a way of describing what happened without actually having to do it. So if we look at our point here, our very first point A has an x and a y, and the x is -3, and the y is +1. Well, that's what this is representing. All of these are the pre-images. Okay, the triangle ABC and the XY, that's the pre-image. Now they're going to turn into the image. So triangle A prime, B prime, C prime, and also the point, this X and Y, is going to become a new X and Y over here, which is the point 3, 1. So take a minute, pause it if you don't have all this written down. Okay, now what we're looking at here is what happened with our x's and our y's when we reflect it across the y-axis. So when we reflect across the y-axis, okay, that's what this whole problem is about. What happened to the point? Well, -3 turned into +3. +1 remained +1. So the x and y value of the pre-image were transformed into the x and y value of the image, and where those numbers came from is whatever the x was, -3, it became the opposite, which is +3. So in math, negative is the way we denote the opposite, right? If it was negative, it became positive. If it was positive, it became negative. The y value stayed exactly the same. And you can check that with the other points. Like this point here is -1, 1. Well, it turned into 1, 1. This point is -1, 3. It turned into 1, 3. So you see with all the points, the x changed its sign, and the y value stayed exactly the same. This is called a mapping. This is a mapping, or you might hear it written as a rule. So that's for the y-axis. There's also a mapping or a rule for the x-axis. There's also a mapping or a rule for reflection across the line y equals x, which again is the diagonal line that goes to the origin. So we'll talk about those in class more. The next thing we're going to do is a rotation. And we're going to do a specific rotation. We're not just going to spin this thing until we get bored. We're going to do a specific rotation. We are going to rotate the same triangle that we had, 90 degrees, counterclockwise, about the origin. And that just means that the origin is where we're going to be rotating it from, or that's going to be kind of our center rotation. So, put my y-axis, x-axis on there, and then I'm going to put my same points that I had before. I'm going to go with -3, 1, point A, -1, 1 will be point B, and -1, 3 will be point C. So I'll connect all my dots here, point A, we have triangle ABC, just like before. Now, a 90-degree rotation, counterclockwise about the origin. And just for your reference, if it doesn't say which way to rotate, meaning it doesn't say counterclockwise and it doesn't say clockwise, you should assume that it's counterclockwise. Because if you'll remember, that's the way the quadrants go on a coordinate plane. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4, and that goes counterclockwise. So, FYI, always go counterclockwise unless it tells you otherwise. Now, if I rotate this 90 degrees, okay, what that means is I'm going to take this point C, I'm going to rotate it from the origin 90 degrees. So hopefully you can see there that that's a nice right angle. I've drawn here with this little line here. You don't necessarily need to draw this line. And you can see that the distance of this little line segment and this little line segment are exactly the same. And that's where the point C would wind up if I rotated this entire thing 90 degrees around the origin. Let me get rid of the little line. And now I'm going to rotate it. So point C, we said would come to here. Remember, it's not going to be C, it's going to be C prime. Point B, come to here, E prime. And then last we'll have point A, come to right here, A prime. Connect all our dots. A, B, C. And there we go. We've rotated it counterclockwise 90 degrees about the origin. Don't forget this was our y-axis, this was our x-axis. let's take a look at what happened here. Our pre-image, we're just going to start with point A. Our pre-image point A was point -3, 1. Our image, A prime, was the point -1, -3. So we can say that triangle ABC turned into, or was mapped onto, triangle A prime, B prime, C prime. But more importantly is we want to discuss what happened with the x and the y value of point A. So for every point in our pre-image that has an x and a y value, which is all the points, for every one of those points, they were transformed in the exact same way. And that's how we get our rotation. So let's look at what happened. In point A, our x value was -3. Our y value was 1. When we look at point A prime, we see that those numerical, or take just the number value of them, the absolute value, has switched places, right? There's a 3 and a 1. Now here we have a 1 and a 3. So I know that the x and the y flip-flopped, right? But if you look, the x was -3, and it turned into the y, and it's still -3. The y was 1, switched to the front where it became the x, but it also became negative. So the whatever's right here in our new point is negative, or it's opposite of what it was. So in our, now this is kind of confusing, in our image, our second picture, the x and the y values of that point come from the -y of the pre-image and the x of the image. So you might have to watch that another time or two if it didn't make sense to you, or you can ask in class. Maybe I just butchered it so bad nobody's going to understand it. All right, the last one is a translation. And a translation, I think, is the easiest one. It's one that you've got a lot of practice doing something very similar to it. So we're just going to make one more x and y axis for our coordinate plane. We're going to put the same exact triangle on there because it's been working so good for us so far. So here's point A, point B, and point C. I'm going to connect them, make a triangle. This is what I do. All right, so here, A, B, C, triangle ABC. All right, so what I'm going to do now is I'm going to translate this triangle. And the way I'm going to do it, similar to what you've already seen me do before, I'm going to duplicate it. And then what I'm going to do is just slide it. So I'm going to slide it to here. So I have my A prime, B prime, C prime. Remember, pause it if you need to catch up. Now, a translation is a slide. You may have seen it denoted like this before, with a little arrow. Right? So it said it went from here to here. So we have the pre-image, and we have the image. So we can say that triangle ABC was transformed or mapped onto triangle A prime, B prime, C prime. And that's pretty basic. But we want to talk about what's going on with the points. And we've been kind of picking on point A a lot, so I'm going to move up here and use point C. And I want you to understand that it doesn't matter which point we talk about, the mapping or the rule is going to be the same regardless of which point we use. And that's how the shape maintains its exact shape no matter what we do to it, because we're doing the same thing to every single point. So point C is -1, 3, and point C prime is 4, 1. So you can take a minute and look at it and see if you can figure out some kind of flip-flop, like the X's and the Y's flip and that kind of stuff. But I'm going to go ahead and give you a little heads up that that is not how it happens. So the translations are different, and I think they're by far the easiest kind. So we're going to look at the X and the Y of point C and we're going to see what happened to them to turn them into the x and the y of point C prime. I'm going to start with the x value, and right here, the x value is -1. So how do I get to an x value of +4? Well, it's pretty simple. I go 1, 2, 3, 4, 5. Now, you guys have plenty of practice with rise over run, and counting slope, and things like that. So what does this mean algebraically, or an algebra equation or expression, that I moved 5 units to the right? Hopefully you'll remember that's +5. Now, how do I get down to the 1? I go 1, 2. And you know when I go down, that means -2. So the mapping, or what the rule for a translation, at least for this specific translation, is that I took the x value and I added 5. I took the y value and I subtracted 2. And that's our mapping. You may see it written like this in your book: x plus a, y plus b. Okay, this is called the general mapping. And that's just saying that to do a translation, you're going to take the x value, you're going to add something to it, you're going to take the y value, you're going to add something to it. Well, here we added 5, here we added -2. Okay, so write down any questions you have. Come in tomorrow ready to talk about this.